Sometimes the most amazing discoveries are hiding in plain sight. I've come halfway across the world to Istanbul to study a small clay tablet that's almost 4,000 years old. We've known of its existence for a very long time, but it's only now that we can reveal its true purpose. I believe this is the oldest example of applied geometry in the world. It's a discovery that will completely change the way we view the history of mathematics. And it's been kept safe right here in the Istanbul Archaeological Museum for decades. This remarkable tablet dates from the Old Babylonian period, 1900 to 1600 BC. It tells us legal and geometric details about a field that's being split after some of it was sold off. This is SI 427. It's the only known example of a cadastral document from this time. In other words, a plan of a field used to articulate real land boundaries. On the surface, an interesting historical artifact. But I've found that there's much more to this tablet. Good boundaries make good neighbours. And what this tablet shows us is that Babylonian surveyors were very good at constructing mathematically precise boundaries. What's extraordinary here, what's been right in front of us for over 100 years, ever since it was dug up, is that this tablet shows us exactly how they did it. One simple way to make perpendicular boundary lines is to use something called a Pythagorean triple, a special kind of rectangle that ensures the sides are genuinely perpendicular. This is an important object to the ancient surveyors because the sides of the rectangle can then be extended by sight into perpendicular boundary lines. This proves that our Babylonian surveyor had a rock-solid theoretical understanding of the geometry of rectangles and right triangles and used it to solve practical problems. One of these rectangles is very interesting. It was cut in half to make a right triangle and then resized to match the length of the sloping boundary of the field. But resizing a Pythagorean triple to match another object was very difficult for these ancient surveyors. It's a mathematical problem we think inspired the creation of another remarkable tablet from the same period. My earlier research proposed that another tablet, Plimpton 322, is a trigonometric table of some kind, but until now we didn't know what problem it helped solve. This new evidence makes its purpose clear. It's a comprehensive list of Pythagorean triples and the information that a Babylonian needed to resize them. The surveyor who made SI 427 might have had 3 or 4 of these triangles hanging on the wall, just like we'd hang a hacksaw or a hammer, and select the one that best matches the slope of the field. Then extend it out to match the field's length. Extending these shapes is not as easy as it sounds because of the Babylonian number system. But Plimpton 322 gives us all the information we need to make these calculations. This new discovery unearths the purposes of both tablets, Plimpton 322 being the theoretical solution for the practical problems that the surveyor encountered from SI 427. I really can't stress enough how important these tablets are, both mathematically and historically. They represent a practical application and theoretical understanding of geometry that was massively advanced for the time. Which makes me wonder, what other discoveries are out there hiding in plain sight?